the electric vehicle world is about to be turned upside down. BYD, one of the biggest names in EV innovation, has just made an announcement that could change everything. Imagine charging your electric vehicle in just 10 minutes. Sounds impossible, right? Well, BYD is about to make it a reality. CEO Wang Chuanfu has revealed a new generation of all-solid-state batteries that could solve the EV industry's biggest challenges. How does it work? And what does this mean for the future of transportation? Stick around as we uncover the science behind this game-changing technology. So why is BYD switching to solid-state batteries? Before we dive into that, let's first explore what these batteries are and why they might just change the future of electric vehicles. At the heart of BYD's recent announcement lies the exciting development of all-solid-state batteries, a technology that could significantly change the landscape of electric vehicles. Solid-state batteries are a direct departure from the conventional lithium-ion batteries that have powered the majority of electric vehicles for over a decade. These traditional lithium-ion batteries rely on liquid electrolytes to facilitate the movement of ions between the battery's positive and negative electrodes. While these batteries have been the backbone of the EV industry, they come with several inherent limitations including safety risks, slower charging times and reduced lifespans due to degradation over time from repeated charging cycles. In contrast, solid-state batteries utilize a solid electrolyte material rather than a liquid. This design shift addresses many of the problems associated with liquid-based electrolytes, offering several compelling advantages. Solid electrolytes are non-flammable, making them much safer than their liquid counterparts, which are prone to combustion under certain conditions. Additionally, solid-state batteries are more durable, capable of achieving higher energy densities, and can potentially offer longer lifespans. These qualities make solid-state batteries a highly attractive alternative for electric vehicles, offering a host of improvements that could accelerate EV adoption and shape the future of clean transportation. But what's so great about solid-state batteries that made BYD decide to make the switch? Let's dive into the advantages that could completely change the game for electric vehicles. BYD's all-solid-state battery technology promises to deliver a number of significant benefits that could, really revolutionize the performance of electric vehicles. From faster charging times to enhanced safety and sustainability, these advantages make the transition to electric mobility even more appealing to consumers. And honestly, they lay the foundation for a future where electric vehicles are more accessible, practical, and environmentally friendly. One of the most thrilling claims about BYD's new all-solid-state batteries is their ability to achieve a full charge in just 10 minutes. Charging time has long been one of the major pain points for electric vehicle owners, with most current lithium-ion batteries requiring anywhere from 30 minutes to several hours for a full charge, depending on the type of charger and the battery's capacity. The prospect of a 10-minute charge represents a monumental leap forward. It really bridges the gap between electric and traditional gasoline-powered vehicles when it comes to convenience. For consumers, this fast-charging capability could significantly change the EV ownership experience. A 10-minute charging window would allow drivers to quickly recharge their vehicles during short stops at rest areas along highways, while running errands, or during a lunch break, making long-distance travel much more practical. Drivers would no longer need to plan their trips around the availability of fast-charging stations, eliminating one of the most common barriers to EV adoption. The ability to charge an electric vehicle as quickly as it takes to fill up a gas tank would bring unprecedented convenience to drivers, encouraging more people to make the switch from fossil fuel-powered cars to electric vehicles. Another standout advantage of all solid-state batteries is their significantly higher energy density compared to traditional lithium-ion batteries. Energy density refers to the amount of energy that can be stored in a given volume. As the world continues to focus on curbing carbon emissions and fighting climate change, the broader adoption of EVs powered by solid-state batteries could be a pivotal factor in reducing transportation-related emissions. More EVs on the road would help decrease the reliance on fossil fuels, mitigating the environmental impact of personal transportation. Furthermore, the improved sustainability of solid-state batteries adds to the positive environmental impact. Solid-state batteries are potentially more environmentally friendly than traditional lithium-ion batteries, as they are less reliant on rare and harmful materials and can be made with more abundant sustainable resources. The longer lifespan of solid-state batteries would also reduce waste, as fewer batteries would need to be disposed of and replaced over time. This reduction in e-waste and resource consumption could make the entire life cycle of electric vehicles more sustainable, contributing to cleaner and greener transportation on a global scale. Finally, the introduction of solid-state batteries that charge in just 10 minutes could significantly change consumer perceptions about electric vehicles. Until now, many drivers have viewed EVs as inconvenient, with issues like long charging times, limited range, and uncertainty about charging infrastructure. BYD's innovation has the potential to eliminate these concerns and reshape how people think about electric vehicles. The convenience of fast charging would lead to a more positive ownership experience, helping to shift consumer attitudes toward electric vehicles. As more drivers experience the ease of owning and driving an EV, the market could witness a cultural shift in favor of electric mobility, with more people viewing EVs as viable, desirable options for their transportation needs. This shift in perception would not only benefit BYD, but also boost the credibility and attractiveness of the EV industry as a whole. BYD's solid-state batteries are truly a game-changer for the EV industry. But with this milestone, what challenges still lie ahead? Let's dive in and find out. BYD's announcement of all solid-state batteries with 10-minute charging times marks a significant breakthrough in the electric vehicle industry. However, despite the immense potential these batteries hold, several challenges remain before they can be mass-produced and widely adopted. One of the major challenges BYD and other companies in the EV battery space face is manufacturing scalability. Right now, the production processes for solid-state batteries are, well, both expensive and complex. Scaling up production to meet the demand for electric vehicles is going to require substantial investments in new manufacturing technologies and facilities. Solid-state batteries differ from traditional lithium-ion batteries in their internal structure and the materials used, especially when it comes to their solid electrolytes. These differences introduce challenges in terms of manufacturing methods, since solid-state batteries need more precise and labor-intensive production processes. To achieve cost-effectiveness, companies really have to develop more efficient manufacturing techniques and invest in specialized equipment. The success of solid-state battery adoption depends on the ability to scale production efficiently and meet market demand, which honestly could take years of research and investment. Another significant hurdle is material sourcing. Solid-state batteries require materials that are often more difficult or expensive to source than those used in traditional lithium-ion batteries. The key material in solid-state batteries is the solid electrolyte, which can be made from various compounds like sulfides, ceramics, or other advanced materials. These specialized materials may not be as readily available as the components used in conventional batteries, potentially leading to supply chain bottlenecks. Additionally, some of these materials could face geopolitical constraints or ethical sourcing concerns, further complicating large-scale production. Ensuring a stable and sustainable supply of these critical materials will be essential for BYD to deliver on its solid-state battery promises. Cost is another major barrier that must be addressed before solid-state batteries can achieve widespread adoption. Currently, the production costs for solid-state batteries are substantially higher than those for traditional lithium-ion batteries. This price premium comes from several factors: expensive raw materials, complex manufacturing processes, and the need for specialized production equipment. For solid-state batteries to become commercially viable, BYD and other manufacturers will need to find ways to dramatically reduce production costs while maintaining performance and reliability. The high initial cost of solid-state batteries could make electric vehicles equipped with this technology significantly more expensive than their lithium-ion counterparts, at least in the short term. This price difference could slow consumer adoption, even with the superior performance offered by solid-state batteries. Overcoming this cost barrier will require innovations in material science, manufacturing efficiency, and economies of scale as production ramps up. Beyond manufacturing and cost challenges, there are technical hurdles that need to be resolved. While solid-state batteries offer numerous advantages in theory, real-world implementation presents its own set of difficulties. One key technical challenge involves maintaining stable performance across a wide range of temperatures. Some solid electrolytes can experience reduced conductivity in cold weather, which could impact vehicle performance in winter conditions. Another technical consideration is the interface between the solid electrolyte and the battery's electrodes. Unlike liquid electrolytes that can maintain consistent contact, solid electrolytes may develop microscopic gaps or resistance at these interfaces over time, potentially affecting battery performance and longevity. Researchers and engineers will need to develop solutions to ensure reliable, long-term performance under various operating conditions. The charging infrastructure represents another critical challenge. While BYD's 10-minute charging capability is, honestly, pretty revolutionary, it will require equally advanced charging stations to deliver this kind of performance. Right now, the current fast charging infrastructure may not be capable of supporting the ultra-high power levels needed for such rapid charging. Upgrading charging networks to accommodate solid-state batteries will require significant investment and, coordination between automakers, charging providers, and utility companies. Standardization will also be important as solid-state battery technology matures. The EV industry will need to establish common standards for charging protocols, battery formats, and safety specifications to ensure compatibility across different vehicles and charging networks. Without such standards, the transition to solid-state batteries could face delays and, fragmentation in the market. Despite these challenges, the potential rewards really make overcoming them worthwhile. Solid-state batteries could address many of the current limitations holding back broader EV adoption. Their superior energy density could enable longer ranges without increasing battery size, while their faster charging capability would, honestly, eliminate one of the most significant differences between electric and gasoline-powered vehicles. The improved safety profile of solid-state batteries could also help alleviate consumer concerns about fire risks associated with lithium-ion batteries. With non-flammable solid electrolytes, these batteries are inherently more stable and less prone to thermal runaway, a critical safety advantage that could make electric vehicles more appealing to cautious buyers. Looking ahead, BYD's announcement marks just the beginning of what could be a transformative period for electric vehicles. While significant challenges remain, the progress demonstrated by this breakthrough suggests that solid-state batteries may soon transition from laboratory prototypes to production reality. The coming years will likely see intense competition among battery manufacturers and automakers to overcome these hurdles and bring this technology to market. For consumers, the successful commercialization of solid-state batteries could mean electric vehicles that are more convenient, safer, and, capable of meeting virtually all driving needs. For the environment, it could accelerate the transition away from fossil fuels by making electric vehicles more attractive to mainstream buyers. And for the automotive industry, it represents both a challenge and an opportunity to, redefine personal transportation for the 21st century. As BYD and other innovators continue to refine this technology, the dream of electric vehicles that charge as quickly as filling a gas tank while offering superior performance may soon become reality. The road ahead still has obstacles, but the destination promises to revolutionize how we think about electric mobility.